So, very good morning to everyone. Very good morning, and good
Yeah, good
morning,
morning, sir.
sir. Good morning. So, this is the fourth. This is the last session about your theory session for MCS 227. That is the cloud computing and the IoT. And this particular session was expected to be conducted on 31st May, but due to some reason, it was postponed. And now now we are conducting this session. So this would be the last session for the paper MCS 227. So let me first discuss the entire session, entire this block, and thereafter there will be a doubt session and doubt say clearing time, where you may put your all doubts. And in between of discussion of this one, if anyone feels that they have some doubts or some questions, you may put your questions there. So let me start. And the block code, which is devoted to the application development for computing and the case system. So we have seen in theoretical last session, we have seen about the various aspect of the IoT. We have seen about the protocols and the introduction of the IoT. What exactly the IoT? How we have seen about the characteristics, various classification about the IoT, etc. So this particular block, basically the first unit discuss about the IoT application development environment. So let us start this one. So IoT application. So we have discussed here. We have to discuss about the IoT application, the essential requirements, then the application development, and then they have framework, popular IoT platforms, and some testing strategies, etc. Thereafter we need to discuss about the security issues in the IoT. So IoT application development. So IoT having IoT, we have seen that the IoT technology is a heterogeneity and the enormous scale, high volume of the data and the dynamism is associated with the IoT. We have seen that the IoT may include heterogeneous amount of uh, devices. So all these devices may having different capabilities, different configuration, and the IoT devices regularly monitoring, sensing the environment, and generate the high volume of the data. That data need to be pre-processed in order to find the hidden pattern or information. Or based on this data, we may predict the future. So this requirement combined the quality attributes can be used to develop a high level requirement for the IoT. So, so the essential requirements for in order to develop the IoT application, the first thing is the adaptability. Like the IoT devices are heterogeneity in nature. Heterogeneity means every IoT device having different capabilities, different configuration. So one IoT device may having a very vast computational power. Other may have a very vast memory power. So the thing is that the devices having the heterogeneity configuration. So every configuration is it might be that most of the IoT devices may having the same configuration, but generally, typically, the devices are whenever we consider the devices are heterogeneous. So that's why due to this heterogeneity, adaptability is become the one of the most essential requirement. So the IoT system consists of several nodes, which will the resource constrained, mobile and wireless connectivity. So IoT devices are resource constrained. They have a limited resources. They don't have a full resources. Just like that, if the IoT device, a particular IoT device which was placed in the forest to monitor the forest fire or the wild animal, the counting of the wild animal, or monitoring the tree life, or monitoring the some nonsense activities in the forest. So the IoT devices can be used in the forest for various reasons: forest fire, or the counting of the wild animal, or monitoring of the trees, counting of the trees, monitoring of the illegal activities in the forest. So there are a lot of activities for which we may use the IoT devices. The basic problem with the IoT device that the IoT device is working with the limited energy. In the forest, you may only have a battery power which is associated with the IoT devices. So this battery power means the energy is a very limited energy you have. And in the forest where you have deployed the IoT device, it is not easy to change the battery. If the battery is drained, it is not easy to change. You have to go personally there in order to change the battery. So the thing is that it is very hard, and it is really not feasible to uh, include a large amount of the battery. Yeah. So thing is that the IoT devices having the resource contents, they have the limited computational power, limited memory power, limited energy, and it is also in the mobility in the nature. IoT device may move from the one location to the another location, and they are wirelessly connected to the internet. And due to this factor, such as poor connectivity and the power shortage, nodes can be connected and disconnected from the system arbitrarily. So, so all these factors make IoT system to be extremely dynamic, and that's why in a physical environment that is highly dynamic, IoT application needs to be self-adaptive to manage the communication between the nodes and the services. The IoT devices should be self-adaptive. Self-adaptive is as per the nature of the environment. IoT devices should have to activate the algorithm so that it may accommodate in the environment. So whenever we focus for the development of the IoT devices, we should have to consider about the adaptability nature of the IoT devices. So IoT devices should be adaptable as per the environment. So IoT devices have to design in a such a way that it is a self-optimizing, self-protecting, self-configuring, resilient, and the energy efficient. So these are the factors. These are the some factors which need to be considered during the designing of the IoT application. That is the adaptability. So the another the another important essential criteria is the intelligence. So intelligence basically refer to the so intelligence basically refer to the to understand and obtain intelligence by making or enabling context-related decision, resulting in the execution of the task independently without human intervention. So intelligence means the capability of the IoT devices in a such a way that it may monitor the environment and take the context-related decision. So whatever region the IoT devices was placed in the scenario, the IoT devices should be capable by the adaptability. It is now started the monitoring the environment, and the intelligence here recommend that the IoT devices should generate the result as per adaptability. So the decision-making context, such as context-aware computing services, predictive analysis, complex event processing, behavioral analytics, etc., fall under the category of the intelligence. Next essential requirement, is the real time. Real time because the IoT devices was placed in the in the environment for monitoring the environment. So in order to monitor the environment, the IoT devices should be very reactable in the real time. Just like for an example, if we have used the IoT device for the telemedicine or the patient care or vehicle to vehicle communication, the IoT devices should be very prompt. It means that as soon as there is some sudden change in the environment, the IoT device immediately have to react and generate the result. Just like that, in the patient care, if the patient, if the pa- in the patient care, suppose that in a hospital, a patient is equipped with the IoT devices, and the IoT device continuously monitoring the blood pressure or the dialysis, the functionality of the kidney, etc. And suddenly the IoT device found that the BP is abnormal, the blood pressure ratio is very abnormal. So immediately the IoT device have to raise the alarm real time. In the real time, IoT device have to raise the alarm so that the doctor may uh, come near to the patient very quickly. So just like that way. So, so real time is the another essential requirement. Requirement similar to security. Security, obviously, whatever the information is passing through the environmental process, environmental results or the data which is being generated and communicated by the IoT devices should be very secure, so that no no one else may to change the data or the environment. Means that security is required is one of the most important criteria for the whenever you develop the IoT application. Similarly, it should be a regulation compliance as per the so regulation compliance uh, basically refer to the system where you need to maintain the data activities as per the government compliance, as per the regional compliance, as per the regional wherever you are implementing the IoT device. Suppose that you are developing the IoT device in your lab, and suppose that this IoT device is going to be placed somewhere in the forest, far away from your lab or your company. So thing is that whenever you are designing the IoT device, you are considering your government laws, your bylaws, your original bylaws during the development. But the original bylaws is being changed by the region, by the country, etc., etc. Somewhere the data privacy taken as a very important data privacy of the human being is taken as a very important factor. Somewhere some kind of the human data may is not very much important as per the privacy concern. The thing is that whenever you are developing the IoT devices, you need to keep in the mind about the regulation and the bylaws of the particular region for which you are developing the IoT devices. So that is the regulation compliance. So many people consider the information as a confidential, such as information like whenever you are accessing the internet, there is a possibility of the privacy leakage. So during the development of the IoT devices, you should develop the regulation compliance as per the regional government knowledge. So data protection rule, etc., etc. You need to follow. Yeah. Now, challenges of the so we have seen about the general requirements whenever we are developing the IoT devices. Now, what are the challenges whenever we are developing the IoT application? So, the first challenge is the inherently distributed. As the IoT devices are distributed among the region, so suppose that in a forest you are placing the IoT device for the forest fire detection. Forest fire detection. A fire in the forest for detecting the abnormal fire in the forest, you are implementing the IoT here. So you need so one or two IoT device may not solve your solution because because the forest is expanded in a very vast region. Forest is expanded in the very vast region. So placing of one or two IoT device may not solve your problem. Even placing of the 40 or 50 IoT devices may not solve your problem because the IoT device is having a limited battery and the limited communication range. Limited communication range. One IoT device may have a 10 to 100 meter maximum communication range. So, as per this calculation, for a forest having the 5 kilometer radius expansion, you may have to use more than 500,000 number of the IoT devices. So these IoT devices are inherently distributed. So you have in order to maintain a real-time analysis data acquisition im- implementation in the IoT devices one of the challenging tasks in the IoT devices. So so any distributed classical approach like centralized development methodology dealing with software components may no longer be applicable in the IoT environment. Centralized like of the things, centralized collection of the data or centralized monitoring or the centralized managing of the thousand devices is not feasible in the case with the IoT. This is the one of the other challenge. The another challenge is the deep heterogeneity. The heterogeneity refer to the different capabilities and different configuration of the IoT devices. Some IoT device may communicate with the MQTT protocol. Some IoT devices may work with the TCP protocol. Some IoT devices may having the different kind of protocol. So this these may be popular in the market in order to popularize their product in the market in order to make their product different from the other companies. They always try to change some functionality in the iPhone device. That heterogeneity itself is a challenge during the implementation of the IoT device. So the because the venture manufacturer various products and the quality of the service requirement, since they don't always follow the same standard and the protocols, which create a challenging factor in the development of devices. Data management, it is another challenge because continuously the IoT devices sense the environment, generate the data, transfer the data. So it itself, so managing of this data and security of this data is a challenging device. It's just like that. The data can be corrupted due to various reasons like a failure of the sensor or introduction of invalid data by a malicious user or the malicious IoT devices. You have placed 100 number of the IoT device in the fire in the forest, and uh, some malicious user come, some malicious person come, some illegal person come, and they are placing 5 to 10 number of their own IoT devices in your forest region, where your IoT devices is already working. So these malicious IoT devices may generate abnormal data, abnormal information. So during the conclusion, this abnormal data may plays a very crucial role, and your overall information may be malicious here. So this kind of the data management and the security required here. Sometimes a wrong data format is also a challenging task here. Application maintenance is another factor. So you should allow your IoT devices to support remote debugging, application update pauses, significant privacy and the security challenges. Maintenance is the other important task. Once you have developed the IoT device, you need to update your software, you need to update your hardware. So the software development, software updation should be remotely enabled. Human is in the loop. Human is always one of the major challenge. Monitoring the human activity is always challenge. So the so it is necessary to incorporate the human behaviors in the IoT application design to understand the underlying requirements and the complex dependencies between the IoT application of the humans. Similarly, the application interdependency. So interdependency. So one of the IoT device is designed for the one particular task, and once this IoT device will generate the result, then only the another IoT device may activate itself with functionality. Some kind of the interdependency. So it here is like that. Detection of the fire forest. So one of the IoT device may detect the fire forest. Another IoT device, as soon as the fire forest has been detected, the another IoT device may start the sending of this alarming situation or raising of the alarm. So some IoT device may design to raise the alarm. Some IoT device may design to call the help center, or some IoT devices may design to sprinkle the water. So this is the interdependencies are there here. So that need to be considered. So multiple stakeholder concern. So multiple stakeholders are there. So the stakeholders having the addresses issue that attribute to the life cycle phases of the IoT applications such as design, implementation, deployment, evaluation, etc. So lacking of this mechanism to address the concern of the various stakeholder and the special skill and the expertise required by the stakeholder to identify components, system control the challenge facing the IoT application development. So there's multiple stakeholders having their own concerns. Some wish to do this, some wish to do that. So the thing is that it is really very challenging task to take a single decision. So because the IoT devices need to be designed for the particular standard decision as per the standard decision. So if the multiple stakeholders are there, so it is really a very challenging task to maintain the one particular decision. Quality evaluation, whatever the information or the data is being generated, so this data, because this in the data is for the critical situation, so there is a little or no tolerance for the errors and the failures. So it is really means that overall system quality is important and must be thoroughly evaluated to guarantee that it is a high quality before being developed. So whenever you are designing the IoT devices, the precision about your data, the correct accuracy about your data is should be very high. The data inaccuracy cannot be tolerated, because suppose that for the forest fire, so if any kind of the if any kind of the warming or the yellow color images is there, so if it is being recommended, if it is being recorded as a fire, so the situation may be different in the very summer season. So just like that. So the accuracy should be maintained. So IoT application development frameworks. What are the frameworks we have to develop the IoT devices? The fundamental components are shown in the figure one. So you see here that comprises of the devices hardwares, including the sensor, controller, microcontrollers, other hardware devices. Similarly, the softwares like application configuration controllers operate from the remote, and communication protocols. So the one is the hardware component, one is the software component, one is the communication component, and thereafter the cloud component to store the data. So this is the framework. So you can see here that the hardware, the one component is the hardware, which is the core part of the IoT devices. Thereafter, we need to manage the software, which basically control the hardware, the activities of the hardware, and thereafter we need a communication channel to send whatever the information is being generated or sensed by the IoT devices, and this data need to be saved in the some cloud platform, because these devices having a very limited memory. They cannot store the entire information as well. This information should be transferred to the some remote location for the further analysis. So we require a communication channel here in the cloud platform to store the sense data, and then once we are getting the data from the hundred or thousand number of the IoT devices, then we are going for the another part of the application, that is the analyzing of the data and accordingly reacting on the data. So device hardwares, device softwares. So we have seen about this device operating system. So this having the another kind of the operating system, like it's Word, we have a Windows embedded, we have a Braille, and the most popular is the Linux operating system. Device applications, so streaming to the cloud, analyzing the local control, etc. Communities and the connectivity. So we have our connectivities. We have our various protocols like Wi-Fi, LAN, WAN, 4G, 5G, or the LoRa protocols that support this communication activity. So you can see here that these are the communication protocols we basically maintain during the IoT devices communication. Cloud platforms, as we already have discussed, that the cloud platforms are very being used for the data collection, management, analysis, and the cloud API. So data application, analytics, cloud APIs, and the cloud applications, we are basically used to collect the data and generate and make a prediction based on the collected data. So some open source platforms are there, like Computing and IoT. this is the one of the open source platform, and it basically allow you to manage the unlimited number. Yes, yes, yes. Sorry. Okay, so my voice is lacking, or the you should. Okay, 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 okay. Yeah, let me. So now it is okay. The voice quality is okay.
Yeah, somehow, okay, sir.
Okay, thank you. So, so we have seen that some popular open source IoT platforms like your car, which basically allow you to manage the unlimited number of the connected devices with cross-device interoperability. So we have a various open source IoT platforms to design the IoT applications. So like a car, like a Machina.io, which basically work with the C++ runtime environment. So every open source environment, whatever the open source environment you can see here, that every open source environment having their own advantage, disadvantage, merit, demerit. Some having the some are most popular for the one particular environment, some other are most popular for another kind of the environment. So depend upon the what the environment, depend upon the what for what kind of the purpose you are using the IoT devices, and in which situation, in which particular environment you are using the IoT devices, and what is the availability and the network connectivity is there. So depending upon the various factor, we have a various kind of the IoT platforms like your car, like your Machina, like your Jetta, like your device Hive. So, like your DSA, so depend upon that what kind of the parameters you may have, what kind of the what kind of the factors you may have. Like your Jetta, it is working with the REST APIs, and it runs everywhere, including on the cloud, PC, or the single board components. It is basically working with the Raspberry Pi and cloud platforms like Heroku. So it also the cloud platform also play a crucial role because you are collecting the data for the further analysis. So your devices should be compatible with the cloud service provider. Just like that, if you are using the Amazon services, Amazon Web Service, the cloud service provided by the Amazon, and your IoT device is not capable, not interoperable with the Amazon Web Services, AWS cloud services, then it will be a challenging task. So that also need to be considered here. Like a device Hive, it is working with the Apache 2.0 license. So any kind of the Java-based application, Java-based communication can be done by the this one. So HTTP-based WebSocket and MQTT-based communication can be easily considered by the device Hive. So this is the one of the most popular architecture in the IoT devices communication activity. It provides rich support for the big data analytics. So not only so this device Hive not only collect the data, not only work with the communication and the communities, but it also provide various analytical tools to generate the result and the prediction of based on the data collected. So DSC, so this is another open source IoT platforms, and it having their own advantage like the lightweight modules, flexible to implement, and DSA query, and some hardware integration supports it basically provide. Another one is the most popular, that is the Google Cloud Platform. So it basically provides various supports like so these are some kind of the softwares for connecting the various IoT devices like Arduino, etc. And it basically provides various this cloud Google Cloud Platform provide us various analytical tools as well to predict the data, etc. So some of the tools for the I2 prototypes like your Arduino. Arduino is a hardware device where basically the IoT sensors and the IoT devices are being placed on the Arduino breadboard. Similarly, we have our SPN, Raspberry Pi, Eclipse IoT. So these are the some IoT hardwares which basically allow you to connect multiple number of the sensor. Depend upon that for what kind of the environment you are designing your IoT hardwares. So these are the some platforms which basically allow you to assemble the assemble and create your IoT platforms. So TSL2, so you can see that what is the size of the RAM and what are the another kind of the uh, flexibility they will provide. Similarly, the platform IDEs, so you can see that 400 embedded boards and more than 20 development members. It is provided. Similarly, we have a Kinoma, like so it having a Bluetooth. It is working with the BLE integrated Wi-Fi. Speaker microphones are also providing. So depend upon this. So depend. So these are the IoT hardware platforms. So depend upon that for which kind of the environment you are designing the IoT devices, and you have to change. You have to choose appropriately the hardware platform. Similarly, the IoT application testing strategies. So whatever the IoT application we have developed, we have to test that your IoT is working perfectly or not. So we have some testing, like we have a performance testing to test the performance of the IoT devices. We have a security testing. We need to check about the security concern of the IoT devices. Similarly, we have to discuss about the compliance testing. Compliance testing is it is compliant with the environment or not. So whenever we have designed, suppose that we have designed for the temperature monitoring, and now we are placing the IoT devices in the forest for the temperature monitoring. It might be possible that and you have designed your IoT device to work between 0 degree Celsius to the 50 degree or 70 degrees Celsius. It might be possible that in the extreme winter season, the temperature down may be lower than the 0 degree Celsius. So definitely your devices should be capable and it should be compliant for this kind of the extreme weather situation. To test interoperable or not. Interoperable means it may communicate with the another platform or not. Your device is working with the Linux operating system, another device is working with the Windows operating system, Windows embedded operating system. So your devices is ready to communicate with the Windows or not. That should be that need to be tested, because you can't control that. You can't create a scenario in front of the customer that your devices is only interoperable with the Linux. So in that way, if you are limiting your interoperable capability of the devices, so your device may not be very popular in the market. Some other manufacturer provide the interoperability. Your devices is not providing the interoperability. Another manufacturer device is providing the interoperability. So their devices will become the dominant in the market instead of yours. So that should be teached. Data privacy and the analytics validation, etc. also required. So at a census level, we have to test about the functionality testing and the security testing at the gateway and the network level. So the census layer means a lot of sensors are there, and these sensors communicate with the one of the gateway and one of the gateway. So gateway level or the network level. So we have test about the network compatibility testing, network connectivity testing. Then so gateway is sending this information to the cloud, some kind of the cloud. So at the cloud level, we need to test about the interoperability testing, functional testing, API testing, and the application layer. Again, we need to test about all these things. So these are the some IoT application testing strategies. So just like that, for the performance testing, we have a various uh, protocols. We have for the security testing, for the complexity testing, we have a various kind of the protocols. So or I already have discussed about this one. So this thing need to be considered with the IoT application deployment. Security issue. Security is one of the major issue in the IoT protocols. So that need to be taken care. Your IoT devices should be designed in such a way that it may authenticate about the connectivity, and then it protects not only from the threats such like your DOS or the replay attacks. If you know about the DOS attack, replay attack. So these are the very common attack on the IoT devices: DOS attack and the replay attacks, etc. So your devices should be more secure. It should authenticate itself. DOS attack or the replay attack only being performed if you are not performing the authentication properly. Authentication means if your device is able to communicate with the another device. So before communicating with the another device, the your IoT device must identify the nature of the another device. Another device. So the another device may be a uh, uh, malicious device, or it may be a legitimate device. So your IoT device should consider about this one. So some kind of the authentication required in order to uh, ignore the malicious devices. So this kind of the things you need to consider in the security layers. So like a denial of service attack, like your hardware jamming, like your insertion of the forge network, brute force attacks. So these are the some kind of the common attacks on the IoT devices. So at the gateway level, again, we have some kind of the uh, high level of the attacks. So if you have a cyber security paper, so you may know about that. What are the nature of this kind of the attacks. Similarly, at the cloud layers, these kind of the attacks are going on. So countermeasures are your authentication, authorization, confidentiality, integrity, and the non-repudiation. So your devices. Whenever you are designing a security protocols, these are the five parameters that need to be verified during the designing of the protocols. The security measures. Whenever you are implementing a security measures, you need to verify the security measures on these five on these five main points. So you can see here that these kind of the things you need to obey. So weak, guessable, or the hard-coded password in secure network services. So these kind of the things you need to manage. So your password should be very hard. Your network services should be very secured. Your device management, you always need to perform the device management. You need to change the default settings. So these kind of the things you need to perform. So you can see here that for the authentication, what you need to do, use security credential, use identity and the access management methods. So authentication and the authorization are two terms. Authentication and authorization are two terms. It having the meaning authentication basically identify the credibility of the user. Authentication basically identify whether the user is allowed to log in your environment or not. So authentication means some is coming and he want to enter in your network. So you first tell him that please show your identity. So showing of the identity and verification of the identity is the authentication. If the particular person is authorized to enter in your is if if that particular person identity is okay, then you are authenticating him to come into the your network. Thereafter, after coming in the network, if the particular device is trying to read a lot of information, the confidential information, general information. So if the particular device is authorized to read the confidential information, then only that is able to read that particular confidential information. So authentication means you are verifying the identity of the person, and in the authorization you are verifying that whether this authenticated person is authorized to access this information or not. So this is the authentication, the authorization. So you can see here that similarly, the confidentiality. So your device may contain a less computational power, so data must be encrypted and only authorized user can access their data. Data integrity, it should be a hashing technique. If you know about the hashing technique, means your data should be converted encrypted in a such a way that it should be decrypted in a same way. So non-tampering of the data, hashing technique basically ensure about the non-tampering of the data. So non-repudiation using the digital signature, etc., so that it should not be copied illegally from anywhere. So this is the end of this unit. Let me quickly go to the another unit. We have a list time here now. So for computing and the edge computing. So we need to discuss about it for computing at the edge computing and the challenges and the application of the edge computing. So we have seen about the cloud computing. So cloud computing is what? A platform which providing lot of services. So suppose that Google is providing the cloud computing service. Google is providing the cloud computing service, or your social media like your Facebook or the Instagram, every kind of the social media platform provide a cloud services. They having their own cloud architecture. So Facebook having their own cloud architecture, Google having their own cloud architecture, Amazon having their own cloud architecture. What is the location of the cloud? It is unknown to the user. Suppose that I am using the Amazon cloud architecture. I am using the Amazon cloud architecture, and suppose that I am in Indian continent, and suppose that the the Amazon has deployed their cloud architecture in the some American continent. I am the user is in the I am in the Indian continent, and the cloud architecture is available in the American continent. So what is the problem here? If I am the user, if I am the only user, then it is very easy to provide me information. Uh, provide me, I can easily access the Amazon services, etc. But the thing is that Amazon is not providing this cloud infrastructure to me only. It having several users. So during the peak hour, Amazon service may having a lot of delay. It may having a latency, lot of delay in order to provide the services to me during the peak hour, because I am very far away from their physical architecture. So there may be a larger communication delay from me to the cloud architecture. So in that way, what will happen? In that way, will happen if another cloud architecture providing me a very if the another cloud architecture providing me the cloud services at a very less communication delay. They are providing the services at a very less communication delay, whereas the Amazon is providing these services with a larger communication delay. So what will happen? Definitely, I will move to the another cloud. So thing is that so what would be the solution? The Amazon may provide the another cloud architecture to the Indian continent. The Amazon need to provide the another cloud architecture to the to each and every continent, to each and every country, to each and every region, which is again not feasible. Which is again not feasible and not good as per the business law. It is not feasible that Amazon may establish the cloud architecture at each and every region, etc. So what the Amazon may do now? The Amazon may identify that what kind of the services are being generally requested from the Indian continent. What are the services are mostly being identified, mostly being generated. What are the service requests are mostly being generated by the Indian continent. So what the Amazon will do now, the Amazon may establish a small cloud for the Indian continent, and of the services that may be provided by this cloud is related to the Indian continent. So the based on the kind of the services, based on the kind of the request, based on the kind of the infrastructure, the cloud services may be deployed into the various regions. So the one is the major cloud, one is the main cloud architecture. This service, this kind of the sub cloud architecture is known as a fog computing. Fog computing, FOG. So the fog computing, it is basically derived from the Cisco. It is basically derived from the cloud computing, and the fog computing is a lesser. It look like a cloud computing, but having the lesser infrastructure. So, horizontal level architecture that distribute the computing, storage, control, and the networking functionality closer to the user along a continuum from the cloud to the device. That is the fog computing. So, fog computing is a cloud architecture which is near to the user. Cloud can be accessible from everywhere, but making a centralized cloud for the entire world may generate latency, generate a communication delay, and generate a heavy computational requirement at a centralized cloud. So cloud is now being distributed in the various locations. That will become the fog computing. So the fog computing features of the cloud computing, which basically related to the fog computing, is the location awareness and the low latency, geographical distribution, decentralized real-time services. We already have seen, I already have discussed all these things, which basically these are the factors which basically generate the region behind the concept of fog computing. Similarly, so if we see the difference between the cloud and the fog, so if we say about the architecture, so in the case of the cloud computing, it is a centralized architecture. In the fog computing, it is a distributed architecture. So fog computing is not replacing the cloud computing. You just always keep in mind that cloud computing is a kind of the centralized architecture which is located in some of the region. Thereafter, we are providing the fog computing to reduce the delay, communication delay, reduce the in order to control the number of the user, rapid increment of the number of the user. So you are providing a sub cloud architecture here. So main cloud is at their place. Main cloud is at their place, and you are creating a sub cloud architecture. So the sub cloud architecture servicing the particular region customer, and then it always communicate with the main, main cloud computer, so that the integrity and the authenticity and the integrity of the data, or the acid property of the data should be maintained in the cloud as well as in the fog. So architecture, so the cloud having the centralized architecture, whereas the fog having the distributed architecture. Location, cloud having the distance location, whereas the fog computing having the proximity to the end of the user, to the end customers. Like for the Indian customer, there may be a Amazon fog. For the Chinese customer, there may be a uh, Amazon fog in the Chinese location, and like that. Resources in the cloud, we require the complete infrastructure, so huge resources required in the cloud, whereas in the for computing we identify what kind of the services is typically asked from this particular continent, this particular region. So that kind of the services is being provided by the fog computing, so it having the limited amount of the resources. Just a minute. computational capabilities computational capabilities. So cloud having the highest computational capability, where the fog having the lower capabilities. Response time, obviously the cloud having the more response time, the fog having the less response time. Now you can correlate between the cloud and the fog. Access can be accessed over the internet, can be accessed by the various protocols. If your communication protocol doesn't only rely on the internet communication, then the fog may provide you non-internet based connection as well. Security in the cloud, we require a less security because every security checkup is going to be done by the fog. So we require not a major security in the cloud, but so all the security is being identified by the geographical distribution. Cloud is centralized, fog is localized. Distance between the client and the service node, so it having the multiple hop, whereas the fog is near to the user, so in a single hop it can be reach. Service provide delay in the real-time services by the cloud because the cloud is the centralized and having it may be a far away from the user location. So the cloud having the some kind of the delay in the service, whereas fog is perfectly suited for the real-time mobility support. Cloud mostly not, fog having the fully support. So for computing architecture, so you can see here that we have a major cloud service, and the replica of the cloud is going to be done with the lesser number of the device, lesser number of the services is your fog. So this is your fog. So you can see here that if this much number of the user are directly communicate with the cloud, so these users may get service delay. They will get the service delay, and they may having a lot of other complication. So that's why we have divided. We have divided the users, that this much number of the users will connect with this fog. This much user will be connected to this fog, and so this fog is providing the services to this number of the user. And if some service is not available to this fog, suppose that some service which is requested by the one of the user is not available to this fog, then this fog may connect with the cloud to get their service. But most of the services are available to this fog. So that is the working of the fog architecture. So this is your fog computing. So application of the for computing for the smart cities. So you can see here that this is the one of the cities. So their services are being provided by the particular fog on here. This is the highway. So highway. So the small fogs we are creating, and these fogs may connect with the cloud for the complete services. So car and the traffic, smart traffics, smart grids. So all the keywords smart is associated with whatever the services is become the part of fraud computing, surveillance, etc. Challenges, complexity, obviously complexity, power consumption, data management, authentication, security, interoperability. Whatever these are the common terms which is always a challenging task for new kind of the technology. So you can easily now go. Now come to the edge computing. So we have a cloud, and then we have created a fog. But it was found that fog is again going to be very busy. Fog is going to again very busy, that having a lot of users. So again, what we are providing, we are again providing now some of the services from the most popular services from the fog to the edge computer. So edge computer is again more nearest to the user. Fog computing was nearest to the user, but edge computing is now coming more nearest to the user. So the basic idea behind the cloud, fog, and the edge computing is that cloud computing we are now segregating the users. We are now segregating the users based on the location, based on the services, and then we are creating the fog. So fog will now service this much number of the user. Now if this much number of the user or one particular fog is being very busy, that having a larger user base, and this particular fog is very busy. So busy due to the number of the users, so communication delay may be there, service delay may be there. So now again we segregate the user into the smaller block, smaller group, and a kind of edge computing is being evolved. So cloud computing having the larger infrastructure, fog computing having the lesser infrastructure than the cloud, and the edge computing having the more lesser infrastructure than the cloud and the lesser than the fog computing. But they are providing all the same kind of the services. So that is the edge computing is more closer to the user. So the edge computing is being mostly used for the smart home. So you can see that for the city, we are maintaining the cloud. For the entire country, we maintain the cloud. For the cities, we maintain the fog. And for the home, we provide the edge. And data updation, validation, maintaining of the data that need to be maintained in all these ones. So all information need to be maintained at the cloud. But this is the way in which that like your smart home, autonomous vehicles, surgical robots, real-time gaming experience are being provided by the each company. You can see here that by the real-time gaming, if if the five players from the five different countries are playing one of the internet game, one of the online games are being played by the five different players from the five different countries. If we only rely on the cloud computing, then it might be possible that these players may experience a service delay, a delay in between their action and the action taken and the action performed. So in the game, so that is not tolerable. If the some other company providing the more accurate or having a very less service delay, so definitely their cloud is going to be more popular. So we need to go for the edge computing. So edge computing, edge devices, edge node, edge server, edge gateway. What is the common the thing is that whenever you are creating a kind of the cloud, you need a node, you need a device, you need a server, you need a gateway. Similarly, whenever you are getting the fog, again this kind of the replica is required. Even you are getting a edge or this kind of the devices or the replica you may require. So the computing having the three primary nodes, edge, local, and the cloud. So you can see here that so so this is the device, this is the local, and this is the cloud. So this is the cloud, this is the fog, and this is your edge. So it is very now easy to understand the difference between that and whatever the virtualization concept, whatever the gateway concept we have seen in terms of the cloud, all are being managed. Similarly, the public cloud, private cloud, we may create a public fog, private fog. Similarly for the edge as well. So cloud in the nexus, edge is edge is fog is more near to you, and the edge is on your devices. So this is the relation between the cloud, fog, and the edge. So you can see here that this is the cloud, this is the fog, and this is the edge. So cloud in the country, fog in your city, and the edge in your home. Just like that. So you can now take a difference between all this one. So cloud centralized approach, fog distributed approach, edge is also having the distributed approach. Cloud having the large amount of the resource, fog having the intermediate, and the fog is having the limited resources. Latency, this is the one of the most important. For that's why we are going for the fog and the edge. So cloud having the highest latency, fog having the medium latency, and the edge having the lowest latency. Low data rate in the cloud, medium data rate, high data rate in the edge, and this is because the high data rate, we are getting the services more promptly and more accurately at a high speed. Globally distributed, regionally distributed, locally distributed, we already have seen non-real-time response, near real-time response, and real-time response. So edge is going to be different. So that is the difference. So application of the edge, now you can easily understand that. What is the application of the edge computing? The smart manufacturing, telemedicine, healthcare, autonomous vehicle, inventory management. So now you can easily understand that and correlate that why we are using the edge computing. So these are the application of the edge computing. So that is the edge cloud and cloud, edge computing, and the fog computing. And one of the most one of the unit is your IoT case studies. So you can see here that the case studies. So whatever we have learned about the cloud, fog, and the edge, whatever we have learned about the cloud computing, fog computing, and the edge computing, Now, by an some scenario, by a scenario, it is being discussed. That is the case study. So here you can see that the case studies for the smart grids, connected vehicles, smart healthcare, IoT, IIoT. So let us. So for the smart cities, so what we are providing with the IoT usage case for the smart cities, why we use the IoT for the smart cities. So you can see here that for the traffic management, for the smart parking. So whenever you are visiting to the particular place, you are visiting to the some remote visitor, you are visiting some remote place, or you want to watch a movie in the theater. So before reaching the theaters, you may book your parking slot like that. So smart parking, public transport, you will get the idea that what are the public transports are there, and promptly, so you are standing at a particular location, you are standing at a particular location in the city, and you wish to go somewhere else. As soon as you have put it your destination, you are getting lot of option, lot of suggestion that which public transport and at which time it is coming here to you. So this kind of the public transport management would be there. Utility management, so transfer, so whatever the utility services is being provided, like your electricity meter reading, telecom networks, gas, the kitchen gas, energy and the water, so LPGs, energy and the water consumed by the per household, extra are being calculated now. So this is the combination of the cloud, fog, and the heat. Street lighting, waste management, environmental well-being. So now you can easily understand that what we are basically using this one. So like your vehicle services, shared vehicle services based on the geolocation, like your Uber, Ola services, like the things. Monitoring the employee attendance remotely, monitoring the user satisfaction, including the data collection for the better air quality, optimizing refuge collection routes, connected dumpsters, etc. You can you can easily understand in the case of the smart cities. Similarly, for the smart home, or you may having a smart lightning whenever somebody enter into the room, light automatically switch on, fan is automatically start the rotating, and as soon as there is no one person in the room, you are coming out from the room, the light and whatever the appliances in the room, they are automatically going to be switched off. So this kind of the smart lighting, smart keychain, smart safety and the security systems, smart bathrooms, all these kind of the automatically geyser, heater, and the AC may switch on off as per your requirement, as per your configuration. Smart gardens. So, so you can now easily understand this one. I don't need to think that we need to discuss more about this one. Similarly, application of the IoT in the agriculture. Now you can easily see that smart farming, monitoring the real-time weather conditions, precision farming, so irrigation management, livestock management, vehicle tracking, etc. are being provided under the precision farming, smart greenhouses, use of the drones uh, for the spreading of the pesticide, for monitoring of the insects, etc. We are using the drones, data analytics, we are taking the crop crop health, mm, crop health status from the different location, and then we are analyzing that if there is a insects in the crops. Based on the data analytics, we may go for the using of the drones for spreading the pesticides, etc. So these kind of the things are now being performed. Another case study is your smart transportation. So in the case of the smart transportation, we are using the CCTV cameras for the efficient traffic management. If one of the route is going to be busy, we suggest the we suggest another user who is approaching to the particular route may divert and take the another route. because that this particular route is busy, traffic is busy on the particular route. So before reaching to the particular route, in the advance, I am getting the some traffic diversion suggestion. So this kind of the traffic managements are going on. Automated toll and the ticketing, uh, automated toll, so toll paying of the toll tax. Now, in the earlier days, you have to stop at the toll, you have to pay, and then once it will confirm, then the toll person uh, open the gate to cross this one. But this introduces a lot of delays, and there will be a huge traffic on the toll gate. You can see 10 to 15 years ago, 10 to 15 years back, so that what are the traffic at the tolls. Now you can see that you don't need to stop at the toll, you are directly crossing the toll. So this is smart tolling system. Self-driving cars, Google cars are coming. Tesla cars are also coming, that providing the driverless cars, etc. So we a lot of techniques are being used here. So it is the beyond the scope of the discussion, but you should know about that the name of the particular technology. Advanced vehicle tracking, transportation monitoring. So where is your vehicle, where you are going, where is your vehicle, at which time you may reach. So everything is being provided by the vehicle tracking services. Enhance security in the public transport, security is being enabled. Similarly, the smart grids, so low carbon energy, basically for the low carbon energy, so is street lighting, transmission line. Smart grid is basically you may correlate it with the electricity distribution. So any kind of the distribution, public distribution, come fall under the category of the smart grid. It may be a electricity distribution, it may be a water distribution, etc. But mostly, let us take an example of the electricity distribution. So smart street lighting, when your street light should be on, off, it is automatically need to be decided. No manual intervention required. Otherwise, if the manual intervention would be there, so you need to hire the manpower to switch on of the street light as per the need. So, by the smart lighting system, you are replacing the human power. So, similarly, transmission lines, substation, cogeneration, outage sensors, etc., are the part of this one. So now you can see it. Smart meters, you do not need to. In the 10 to 15 years back, somebody need to come near to your home, near to your electricity meter, to record that how much you have how much electricity consumption for this particular month, and that particular person will send this information, manually send this information to the substation for generation of the billing amount. Now it is automatically being done. So, so these are the smart energy, clean energy, lower cost. So we are replacing the human power. We are replacing the huge human requirement in the transmission line or the in the meter reading. So that cost is going to be reduced. So overall cost is going to be reduced. This kind of the example you can see here. In the case of the connected vehicles, we have connected cars. So one car is going passing. Suppose that one car is passing away uh, from your. Uh, uh, there is a distance between your car and the car ahead is going from your car. So if there is a 2 kilometer distance between your car and the car is going ahead to your car. So if the front end car is getting any kind of the observation, any kind of the alarming situation, so that particular car may reach the alarm. This is going to be identified by the IoT devices alarming situation, and you are being notified for this alarming situation before reaching to there. So you may take a different route, or you may take a necessary precautions, etc. So connected cars are there. So features of the connected cars, so internet connectivity in the cars, app to the car connectivity, geofencing, etc., vehicle communication, entertainments are going to be there. Remote parking before reaching to you, your parking space is already reserved. Security, so types of the connective vehicle to infrastructure, vehicle to vehicle, vehicle to cloud. Vehicle to infrastructure means this is a road. This is the road your car is passing. So at a some distance, we are placing some kind of the road infrastructure, so that this car when passing, whatever the IoT devices generated the data that is being transferred to this one, and this roadside infrastructure communicate with himself. So before reaching to your car, the information is coming to this infrastructure that your car is coming. Similarly, suppose that there is a toll, there is a toll at this road infrastructure. So this roadside infrastructure, getting the information that this car is approaching to this. So before coming this car to this particular location, the car authentication and all information are already being fetched with the help of pre-road infrastructure. And as soon as the car is approaching to you, your toll is clear, and you do not need to stop your car. You can directly cross the toll, and the whatever the toll amount, it is already being deducted from your concerning account. So these kind of the thing are going on. So this is the vehicle to infrastructure, vehicle to vehicle to cloud, vehicle to pedestrian, vehicle to everything is coming. Similarly, in the smart healthcare, so IoT for the patient, IoT for the physician, it is not required that the patient and the physician should be close proximity if it is not an emerging situation. So, uh, accordingly, it is checked. So advantage of the healthcare: cost reduction, improved treatment, faster disease diagnostics, etc. These are the some of the advancement of this one. So now you can easily understand that what are the advancement of using the IoT applications. So, so in the patient care, so now it is not required that the doctor and the patient should be in the same hospital. They may be at a different location, and as soon as uh, so in the case of the smart healthcare, so proactive treatments, etc. You can the robotic surgery from specialized doctor are available in America, and from sitting from there, he is instructing to the robots, and the robots is performing your surgery. So these kind of the things are these are going in a more smart way. It is coming glucose, these kind of devices here, and I think monitoring device and the more monitoring of the key letters. So every time the disease monitoring are being now developed smart vehicles. Some at a some we already have achieved the whole similarly for the industrial IoT, industrial automation, industrial things that are monitored their assembly lines, their production, everything is going to be monitored by the IoT devices. So no human the placing of the human somewhere in the assembly line may create a problem to so is that etc. Use of the cloud processing, cloud collect performance and statistical analysis. We cannot put at the fog at the edge, because the edge and the fog having the limited resources, limited energy, whereas the cloud having the infinite energy and resources. So all kind of the processing are being done at the cloud. So internet gateways. So gateway, the task of the gateway is to pass your data traffic to the cloud. So filtering of the data traffic, whatever the information coming to your network, to your edge, that need to be filtered, because the internet is working with the IP.
Sylvester, is the class over?